Hello, this is Mrs. Myers, and we are going to be learning about trapezoids and kites today. A trapezoid, by definition, remember we said definitions of quadrilaterals are really important to be precise. A trapezoid is a quadrilateral. Remember, that's a four-sided polygon with exactly one pair of parallel sides. So it's not just that it has to have a pair of parallel sides, it can only have one pair. Otherwise, it would be considered a parallelogram, and that's a completely separate category. Okay, so a trapezoid has exactly one pair of parallel sides. There are parts of a trapezoid that have specific vocabulary. The bases are the two sides that are parallel. The legs are the non-parallel sides. So this is a leg, and this is a leg. They're not parallel to each other. The base angles are the two angles down here and the two angles here. There's two pairs. I know it seems like all four are called base angles, but you have to think of them in pairs. These two are the red ones here are the base angles that go with the top base, and then the blue angles I have down here are the pair of base angles that go with the bottom base. Okay? All right, an isosceles trapezoid is a trapezoid with legs that are congruent. So if you remember back to the word isosceles when we talked about triangles, an isosceles triangle had two sides congruent. Well, same thing with a trapezoid. If it's isosceles, then it has two sides congruent. So in this case, it's the two non-parallel sides, so the two legs. Remember, the legs are the non-parallel sides. The two legs are congruent. When a trapezoid is isosceles, it has certain properties that aren't true of any old trapezoid. They're only true about isosceles trapezoid. So there's two theorems here that talk specifically about isosceles trapezoid. Okay, so these are all just about isosceles traps. Okay, the first one, if it's an isosceles trapezoid, then the two pairs of base angles are congruent. So R is congruent to A, those are the top pair of base angles, and T is congruent to P, those are the bottom pair of base angles. Remember, you think of base angles in pairs. You wouldn't link up these two. Those two don't go together. You're talking about the top pair here and the bottom pair here. Okay? So the two pairs of base angles are congruent. The second theorem, also about isosceles trapezoids, is that if the trapezoid is isosceles, and only if it's isosceles, then the two diagonals are congruent. Those two angles, those two diagonals are the same length. So if you think about in GeoGebra, the isosceles trapezoid, when you move the quadrilateral around, the two diagonals were exactly congruent if the trapezoid was isosceles. Okay. The midsegment of a trapezoid. Now, this is for any trapezoid now, not just isosceles trapezoid, but the midsegment of any trapezoid is the segment that joins the midpoints of its legs. Sound familiar? Hopefully. Remember, midsegment of a triangle was something that we learned before. Right? If we had midpoints of all the sides, and then we connected them, that was called the midsegment. Sometimes we drew all the midsegments in, or you can just think about the one midsegment at a time. Oh, sorry, I just hit the microphone. Sorry. The midsegment that is in a triangle was the theorem said two things were true. That midsegment was parallel to the third side and half the length of the third side. That was true about midsegments of triangles. A little bit different for trapezoids. The midsegment of a trapezoid, same definition, it's joining the midpoints of the two legs, so the two non-parallel sides. If you join the midpoints, you're going to get a midsegment that is parallel to the top and bottom of the trapezoid. I shouldn't say top and bottom, I should say to the two bases of the trapezoid, right? Because I could turn this sideways and it wouldn't look like the top and bottom anymore. This. But you still, by mid-segment, you want to connect the midpoint of the two legs. Those are the two non-parallel sides. And it will give you a mid-segment that's parallel to the two bases, in other words, the parallel sides of the trapezoid. Okay, once you do that, yes, it's parallel to the two bases, but it also is half the length of the sum of the two bases this time. In a triangle, it was half the length of just the one base. But really, if you think about it, we could have said it was the sum of the two bases because the triangle has a base of 0 at the top, right? There's 0 there, so it's half of just the one. Here, it's half of the two bases added together. So we have Mn equals 1/2 Tp plus Ra, or again, it's going to be this formula. 2 times the midsegment equals, and then think of it as base 1 plus base 2. Base 1 plus base 2. 2 times the midsegment equals base 1 plus base 2. So if we look at some of these problems here that apply these theorems, number 1 says CDEF is an isosceles trapezoid. You can see that these are marked congruent. And the measure of angle C is 65. What's the measure of angle D? Well, if this is a trapezoid, that means the top, in this case, and the bottom, in other words, the two bases are parallel. Therefore, these two angles in question here are same side interior angles. So they're going to be supplementary. So 65 plus the measure of angle D equals 180. And the measure of angle D equals 115. All right, but then it asks us for the measure of angle E and F. Measure of angle E, well, we said in an isosceles trapezoid, based on this theorem here, in an isosceles trapezoid, the pairs of base angles are congruent. So, back to this problem here. If this is 115, that means this one would have to be 115. So E is 115 as well. And then F would also be 65 because of that same theorem that says base angles are congruent in an isosceles trapezoid. Okay, if CDEF were not an isosceles trapezoid, would C and D still be supplementary? So let's make this trapezoid not isosceles. Maybe that still looks a little too isosceles. Not isosceles. So these are parallel, and the two legs are not congruent, not parallel. Would C and D still be supplementary? What do you think? hopefully you're thinking, this is parallel to this. These are still same side interior angles. So yes, by the same side interior angles theorem, they would still be supplementary. Okay, find the length of the missing segments in the next part. This is using that 2 times the midsegment. Let's put an x here. I can put an x here because there's no other x's in the diagram. X values, I should say. There's a point x, but there's not an x value. So 2 times the midsegment equals base 1 plus base 2. So 2 times the midsegment, I'm calling x, equals base 1 plus base 2. So 2x equals 22 and x equals 11. Find the length of the missing segment. So we need to find AB, and that's just 11. All right, so you guys try B on your own and try number 4 on your own. Pause the video now and then come back. Okay, so 2 times the midsegment equals base 1 plus, this time x has to be one of the bases, so 2 times 19 is 38 equals 13 plus x, and x equals 25. Down here, again, 2 times the midsegment, parentheses x plus 2 equals base 1, 4x minus 10, plus base 2, 8. And you can solve this. Don't forget to distribute. And then solve. Okay, so you guys could try these 2 on your own. Make sure you are setting up your equation, and then make sure you come back to check your answer. Okay, so you can check your answers here, and we're going to move on. All right, so a kite now. We talked about trapezoids, now we're talking about kites. Kites and trapezoids are the 2 quadrilaterals that don't come under the parallelogram category. Right? We had parallelograms, and then we had rectangles, rhombuses, and squares, and they all came under that parallelogram category. Now, kites and trapezoids, what they have in common is that they're both not parallelograms. So a kite here has no pairs of parallel sides. It's got 2 pairs of consecutive sides congruent. In other words, 2 pairs of sides that are next to each other. Oops, I went the wrong way. 2 pairs of sides that are next to each other, consecutive means next to each other, that are congruent, but not opposite sides congruent. So a kite has to be not a rhombus. It's got to be all the sides, not all the sides can be congruent. You can't have opposite sides congruent. So it has to be 2 pairs of consecutive sides congruent, so it literally looks like a kite, like you would fly a kite. Okay? Then there's some theorems. That's the definition. Remember we talked about definition of kite, 2 pairs of consecutive sides congruent, and not opposite sides congruent. That's the definition. And then there's properties of kites. Properties are different than definitions, but they're always true, so they're written as theorems. If a quadrilateral is a kite, then its diagonals are perpendicular. So when you connect the vertices, just like when you have often a kite that you fly has a pair of cross diagonals here, they're always going to cross at a right angle if it's a kite. So the diagonals are perpendicular. What happens then is that this kite, the one diagonal is going to bisect the pair of opposite angles. You may remember this from GeoGebra also. Okay, so the one diagonal cuts the two angles into two congruent angles. But the other diagonal does not. This one does not. Okay, so you have to look carefully at that. When you get to a problem like number 7 here, what's the measure of angle 1, 2, and 3? Well, angle 1 is a right angle because diagonals are perpendicular. That you should know. Measure of angle 3 is going to match the other one because that one diagonal cuts the other one in half. Cuts the two opposite angles in half. So angle 3 is going to be 52 degrees as well. And then the measure of angle 2 we can find because it's part of this triangle. So measure of angle 2 plus 52 plus 90 should equal 180. And that's going to be 38 degrees. Okay, so that's true for number 8 as well. It's a very similar problem. You can try that one on your own. On the back of the notes here, we just have a little bit of a visual as to how you can classify quadrilaterals, relationships among quadrilaterals. This is like a family tree of quadrilaterals. That's what I call it. So quadrilateral is the big category. You've got 3 types of quadrilaterals, 3 basic types of quadrilaterals that come off as branches. You've got kites, trapezoids, and parallelograms. Kites have no pairs of parallel sides, trapezoids have 1 pair of parallel sides, and parallelograms have 2 pairs of parallel sides. So those are the 3 basic types of quadrilaterals, special types of quadrilaterals. Of course, I could put a 4th type here that's just a random quadrilateral. You know, nothing special, just 4 sides. It could be like, oops. Oh, that looks like a trapezoid. Ay, ay, ay. It's not a trapezoid, it's not a kite, it's not a rhombus, not a rectangle, it's not a parallelogram. It's nothing special. That would be the other type of quadrilateral. But these are the family tree of the special quadrilaterals. Okay, so under trapezoid, there's 1 special type of trapezoid, and that's an isosceles trapezoid. Under parallelograms, we've talked about this before, 2 special types of parallelograms. A rectangle has 4 right angles, a rhombus has 4 congruent sides, and if you take all of the properties of both of those and combine them, that you get a square. So a square is a rhombus, which is also a parallelogram, which is also a quadrilateral. A square is a rectangle, which is also a parallelogram, which is also a quadrilateral. So if you think about sometimes, always, or never, a square is always a rhombus. A rhombus is always a parallelogram. A parallelogram can always be classified as a quadrilateral. If you go the other way, a parallelogram is sometimes a rhombus. A rhombus is sometimes a square, not always. A quadrilateral is sometimes a parallelogram, not always, because sometimes it's a trapezoid. So if you're going down, it's sometimes a trapezoid is sometimes an isosceles trapezoid. The never would come in. A rectangle is never a trapezoid, right? Never. You can't go between branches like that. That would be the never. Okay? All right. This chart down here, see if you can place a check mark and fill out those properties the best you can between kite and rhombus. And we'll see you tomorrow. Thanks.